when we talk about radioactivity, is one of the most topic that is so exciting. Radioactivity is a topic that makes you start now to understand the reason why people get cancer once they're exposed to some kind of radioactive materials. And radioactivity is a topic that gives us an understanding as to why some of the metals, some of the substances are not actually stable, and they continue to decay, to decompose into some other forms of some other simpler substances for their stability. So in this video, I'll be talking about radioactivity, of which this is the second part of the video. The introduction is there, so just check out the video on this same platform, Radical Academy. So I welcome you once more to this platform. Okay, so now we talked about some of the what is radioactivity, which we did in the first part. We also talked about the detection. We also talked about some of the characteristics, okay, the nature of radioactivity. We talked also about some of the instruments that can be used to detect radiation, to detect radioactivity. Okay, now just to revise and to go quickly, we said that radioactivity is the process by which some radioactive element they emits some rays, which are three types of these rays: the gamma, the alpha, and the beta particle. Okay, so now I want now to dig much more deep into the concept of understanding what is known as radioactive decay. Okay, now we need to understand that when radioactivity is taking place, the elements that are involved in the process of emitting those radiations, they are doing that because they are not stable. Okay, so radioactive decay occurs because elements are not stable. Okay, that is one of the key concepts that we need to understand about why radioactivity is taking place. Radioactivity is a random process, and this random process means that we are more exposed to radiations. Okay, so there are high chances that we can get cancer from the unknown things that we are not even aware of. Okay, these elements are all around us, even the sun itself. Sun, or you can say outer space, or even some rocks, even some air, say. Okay, so these are also some of the sources of radioactivity or radiations. Okay, so radioactivity can come from the sun, can come from the space, from the outer space, or even in the rocks. Okay, so now there is what we call radioactivity that comes or that takes place from the outer space. Okay, including the sun itself. We call it the cosmic rays. Okay, so the radiation that comes from the outer space, we call it cosmic rays. So please understand that cosmic rays, this is a radiation that is coming from the outer space, including the sun, as well as you also have the rocks. They can also produce some elements that are very dangerous, and these are part of the earth structure, and meaning each and every single day we are naturally exposed to radiation, of which at the end of the day we can develop some cancer on our body, and we even get surprised to say, where did this cancer come from? It is because radioactivity is a random process, so make sure we understand that it is a random process. It is taking place each and every single time, okay, that ticks. Okay, and then let's now understand about the nature of radioactivity. I want you to understand that when you are talking about the nature of radioactivity, we are simply saying that, how can I know that this is a radioactivity? This is the way radioactivity is all about, or this is how it is in its natural form. Now, radioactivity, first of all, they undergo, or it undergoes decay. Okay, now what we mean by that, radioactivity undergoes the process of what we call decay, decomposing into simpler forms. Let's say, for instance, you have uranium 235. So you discover that uranium is the high grade radioactive element, meaning it is very radioactive. It produces powerful radiation that can even make you become paralyzed, okay? That can make you even start changing your skin color. That can cause you to start moving, your skin becoming pale, because it is killing some of the cells inside your body. So uranium is a highly grade radioactive element, and it is one of the elements that has been known to be used in the development of a nuclear weapon or nuclear power station or nuclear energy stations. So undergoes decay. Now the reason why they are undergoing decay is because these elements are not stable within their nucleus, okay? The protons and the neutrons are not stable. So each and every time when they produces those rays, they kind of reduces in the number of proton and the neutrons, so as for them to become stable. And then the other thing is they undergo ionization. Now they also undergo ionization. So one of the nature or one of the characteristic of radioactivity is that they undergo ionization. Now this is just production of ions. So the production of ions is what we call ionization, meaning that is knocks out the so since radioactivity, we cannot see it with our own naked eyes. So as these elements, they are producing these rays, okay, that are radioactive. They are moving in the atmosphere, okay? They are moving in the atmosphere. And then they kind of collide with the air molecules, the oxygen. So they kind of remove the electrons from the oxygen atom, thereby leaving more positive charges, more positive particles within the air molecules, which is the oxygen or the air molecules, okay? So they knocks out the ions, the electrons, leaving more positively charged particles, which are the protons, okay? So that is the meaning of they undergo the process of ionization, and then they can damage the living things, including animals, even plants. Okay, so you discover that these radioactive elements, okay, they can even damage the living things such as animals, plants, and they can also kill the bacteria. So on this part, it's kind of also, it has some positive and some advantages as to it can even, when someone is exposed to radioactive, device which produces these rays, can kill your cancer, okay? It can kill the cells that are infected with cancer, and thereby probably curing you from cancer, okay? But the main general point is that radioactive elements are characterized by damaging living organisms such as animals, plants, even bacteria, okay? Okay, so they can damage the living things, animals and plants and so on. And then radioactive element or radioactivity is also characterized by when these rays, I can give one of the real life example. You have taken a picture before, and then you discover that part of the picture, the film that develops the picture, at some just on the same picture, on the particular area, there is a spot that is very darker, okay, that is very dark, which results, which makes the photo becomes too dark, and the photo is declared to be kind of bent, okay? So meaning that when radioactive elements or when radioactivity is taking place, they can cause a photographic film plate, okay, to be darkened, okay? And that part, okay, which is darkened on the part of the photographic photo or the plate, it means it reacts with those particles there, meaning as the cameraman was shooting, then it kind of reacts, and then thereby causing or developing the dark part of the photo, meaning they cause the photographic film plate to become so, meaning which is declared that the picture is bent. So the cameraman will say, let us actually redo the photo. Okay, now let's talk about the three types of radioactivity. So the first one is so when these when radioactivity is taking place, there are different kind of radiation that are produced depending on what kind of that radiation is being emitted from that source. So the first, the type of radioactivity or radiation that is produced by radioactive element is called alpha particle. Now when the question comes and then the examiner says, what is an alpha particle? Okay, so an alpha particle, it is an helium atom. Okay, helium atom, that is if I'm not mistaken, okay, is an helium atom. I think, let me just. Okay. You can confirm that on the periodic table. If you have made a mistake, then it is 4 on top or 2 down. So in the actual sense, the alpha particle, when the radiation, when an element that is in nature, a radioactive element, is now emitting that radiation, then it can either emit this kind of radiation, which the particles, the alpha particles, then that is what we call an alpha particle, which is just an helium atom in nature. When you go to the periodic table in group 8, you find helium. Okay. And then it has a highest ionization power. So ionization power, when it is now emitting with the air molecules, it can knock them all. Okay, it can knocks it knocks all the electrons from the air molecules. Okay, so it has highest ionization power, meaning it can cause the air molecules to be knocked out and be left with more protons than the electrons. And then this, it has a lowest penetration power. So it has a lowest penetration power, meaning that it cannot penetrate into this board. Okay, so when the ray, which I can't see, comes in contact with this board, it can immediately be stopped because they are not so powerful. They don't carry so much energy that they can cause, or they can penetrate into this board. Okay, so they have a lowest penetration power. Okay. Now, what happens is that when this radiation is taking place, where the alpha particle are the one that have been released. So what this happens is that if I say, for instance, that americium 237 and then 95, for example, is a radioactive element, then it is now producing the alpha particles, okay, or emitting the alpha radiation. Then we can do that, and then plus. So what this means is that this radioactive element is going to lose 2 electrons, okay, 2 electrons, in fact it should be 4, okay, 4, it is going to lose 4 electrons. So what you say, 237 minus 4, you get 233, and then 95 minus 2, you get 93. Now this is what we call a decay equation. When you go on the periodic table, you discover that you are going to have an element with the mass number of 233. Of course, you will not find exact 233, but you actually confirm with the number at the bottom, which is the atomic number or just the proton number. So you discover that you can get this element. Let's say, for instance, it is known as X. So when you go on the periodic table, this element can be named according to what you get on the periodic table, or under those what we call transition elements. Okay, so this is all about an alpha particle, but these are the key concepts that I'm giving you. Okay, so it doesn't mean that this is all about this thing. And then number 2, we have beta radiation or beta particle. Okay, so now what is a beta particle? Just like I asked in the first place, what is an alpha particle? So a beta particle is just a fast moving electrons. Fast moving electrons. And then the symbol for this beta is just B, the Greek B, like that. The symbol for alpha is this one for variation mathematics, so that's the symbol. And now, this one, it has a medium ionization and the penetration, ionization and penetration power. Okay, so a beta particle is in terms of ionization it is lower as compared to the alpha, but in terms of ionization it is higher, penetration it is higher than the alpha. Okay, so you discover that if I get this a plain paper, and then imagine that an alpha particle is being emitted by a radioactive source, then it can penetrate to the other side of this paper. So because the penetration power is kind of medium than the alpha particle in terms of penetration. Okay, now when you are asked, or maybe coming to the decay equation, then for this one we understand that an electron has a symbol of E, and then I think it should be -1, then 0 there. Okay, so let's say if this same element is now emitting a beta particle, then what happens in terms of the mass number for this one and the proton number is as follows. So americium 237, then 95 emits an electron that, if I have not made a mistake, then it is the opposite, but let's hope I have not made a mistake. So this is going to be the mass number for this radioactive element will not change. You just say this plus that. Okay, and then this will increase by 1. Okay, this is going to be 96, and then you are going to form an element called Y. So when you check out on the periodic table, you discover that this will be a particular element. It will be changed from another element after this radioactive element has now undergone a beta emission or an alpha emission. It changes into other form of radioactive element. Probably the reason is for them to become stable, so that at the end of the day they no longer produce these things that are dangerous to the living organisms such as plants and the animals. Okay, now the last type of radioactivity is the gamma radiation. Okay, so welcome to the last part, which is the gamma radiation. Now the gamma radiation is not a particle